Okay, so we're continuing. This was problem for those of you who are watching at home, which is it's only one person probably. Oh, by the way, let me just mention this really quickly. If I share my screen, because some of you are complaining that you don't see it in time. So if you go to my YouTube channel, let's see, I've got 50 subscribers. Nobody watches it very much, but here, let me do it this way. I know I've got a link here, my channel. If you click on the, for example, let's pretend that we're watching this last view. So I will be the second view on this one. You can click on subscribe. Where is that? It's because I'm in, you can't see it. Yeah, well, let me subscribe. But anyway, there's a subscribe button, so find it. All right, so going back to, that's not what I wanted. Oh, actually, it is what I wanted. I just don't want us to share anymore. Okay, all right. So we're doing problem 15.12, excuse me. So actually, so here's what it says. It says here, so I've got the picture already drawn on the board, and sorry for tuning late. Part B says, use the central limit theorem to find the probability that the average, and I'm going to use X bar because we're talking about X bar now, right? In 50 traps is greater than 3.0. Okay? So Ashley, you know how to do it now?
I don't think so.
You don't think so? Okay. There's no ideas at all? We'll go to Brady here in a second if you don't have an idea.
Yeah, let's go to Brady.
Go to Brady. Brady, you got her off the hook.
Okay, so you take 3.0 minus 2.4. Did you take the?
Okay, before you do that, I know you're reading off your paper, but and it's probably correct. But I want other people to understand why you're reading those numbers off your paper. Okay?
Yeah.
So really what I'm saying is, what equation are you supposed to use?
The z-score x minus.
Z-score, okay. That's exactly right. So we're using the z-score equals
X minus u divided over standard deviation.
sigma over the square root of n. And the only thing, this is a little bit piggy, but this is actually X bar. Okay?
Yeah.
So that's the equation. So now that you've got the equation, Ashley, Brady gave you a big piece of help there. Can you do it?
Maybe, let's try.
Okay?
So you have 3.0
3.0.
minus your mean, which is 2.4.
Your mean, which is 2.4.
Over your standard deviation, which is 0.52.
Well, yeah, it's actually, you could write it that way, but it's this whole thing.
Oh.
It's 3.7 divided by square root of 50. And there's probably more decimals than just 2 decimals, right? So if you want to be more accurate, especially if you're using the computer, don't round to 0.52, let it use all the decimals. Okay? Does that make sense?
Yeah.
I know it's far away, but I got to bring the board over here to see my camera. Okay? Do you have a question, Brenda?
I don't understand why. Is that 3.0?
3.0.
And for the X,
That's what it asked us for.
that's so you're finding the z-score.
We're finding the z-score. That's correct.
Okay, so that's the X bar is the sample mean.
Well, we want to know if the sample mean would be, the probability that the mean would be greater than 3.0. Yes. So essentially, remember, what did we forget to do? We forgot to ask ourselves the question, what would Rick do? And what did you forget to do?
Draw a picture.
Draw a picture of what curve?
The
Bell curve, okay? Drawing a picture of the bell curve here. What is the mean of my bell curve? 2.4, right? And what letter do I use for 2.4? U. Okay. All right, so I've got a mean of 2.4. The standard deviation is 3.7. So if I add 3.7, you don't need to do this, but I just want to do this. So 2 plus 3 is 5, so this is 6.1. And minus 3.7 is going to be a negative number. Okay, so so clearly this is going to be a negative number of beetles, right? That doesn't even make sense. Okay, so really this is actually a more accurate picture. Okay, I've got a mean of 2.4 beetles, standard deviation 3.7. That's going to be 6.1 out here, and then I'm not going to get less than 0. But if I could, it would be a negative number. If you could get negative beetles in a trap, doesn't even make sense, right? Because clearly it's going to stop at 0. So clearly this is right skewed. Okay, it didn't tell us that, but clearly it's got to be. Okay. All right. So now the idea here is using the central limit theorem. I've come along here and I've got 3.0. That's my x bar, correct?
Yep.
Okay. So the idea here is I want to know this area to the right. What's the problem? Because the question says greater than 3.0. So I've got 3.0 beetles in there or greater. What's the probability that happens? Okay. How do you find that area to the right?
Find the z-score.
Find the z-score. So what I've done is I've converted this. I've now converted this to a normal distribution, which it's not, but I've converted it. That's 0. And this answer is going to be 0.6 divided by negative 0.52, which is going to be
1.15.
1 point what?
1.5.
1.5?
1.15.
1.15.
And then you go to your table.
Okay, so now I'm 1.15 standard deviations away, right? Okay, I want to find the area to the right. You can go to your table, which you'll need to do on your test on Thursday. But if you take the computer test tomorrow, what are you going to need to do? You're going to need the computer, right? So let me pull up Excel for a moment. Okay. Well, that reminds me, I need to drop off these darn tests. Or formula sheets. I got to do that today. Okay, so if I'm using the table, how do I use this table? I'm doing a written test. Because you're going to get a different answer depending on whether you're going to get the written or the computer. So the written answer will be, am I sharing, by the way? I'm not. Let's share. Okay, now I'm sharing. Okay, so if I'm doing this on paper, how do I do this on paper? I got 1.15, right?
Go to the back of the book and find 1.15.
Yeah, or this is what you're going to see on your thing.
Okay.
Because you won't have a book.
So it's like
1.15 is 1.15 is that number right there. Okay? So this answer is?
So you do the same.
and then
You do 100 minus that.
So it's going to be 1. Oh, it's already dead. I'm done with that marker.
So you take 1 minus that number.
1 minus 0.8749.
You get 0.125.
So equals 1 minus that number there. So on paper, you'll get 0.1251. Okay. The probability you find 3 beetles or more in a trap, a mean of, is about 12.5%. Okay. How do you do this?
percentage, or you go or
Just leave it as a decimal.
Leave it as decimal.
Just leave it as decimal.
We'll get documented as percentage.
Right. Okay, so how would you do this with the computer? No, not the same way. What's the computer command you would use to find this area? So you're still going to do this. You're going to find your z-score. You're going to get one. Actually, let's do it here. Let's find your z-score first. So z equals. I put the z equals 3.0 minus 2.4 equals 3.7 divided by the square root of 50. So I'm going to take this number divided by that number is 1.1467.
That's how you want to do it?
On the computer, that's how I want you to do it.
That is the same way.
Well, it is similar, yes, but I got more decimals now. Okay? Now I take my z-score, 1.1467, and how do I find my p-value?
You look on the table.
No, you don't look on the table.
Wait,
Now you are going to have the table, but don't look at the table on the computer test.
restate the question.
How do I find the p-value using Excel and not using this table?
Equals z-test.
No, not equals z-test.
Is it,
Is that the correlation one?
Equals norm s dist. Did I not show you this? It's a good thing we're reviewing this, okay, of that, okay? Now, the problem is this Excel works the same way that chart works. It always tells you the area to the left. Do I want the area to the left? I want the area to the right, okay? So if I do this, it's going to give me 0.8742. Actually, if I move this over one, you'll see it's actually got more decimals, okay? And so I want 1 minus that, okay? So whereas the first time we got 0.1251, now we got 0.1257. So it's off a little bit, okay? But this is the method that I want you to use on Excel, okay? So the rule is, and by the way, on your formula sheet, I've got all of your Excel commands that you need to know right there.
so that one's on there?
Yeah, here, in fact, I'll show you on, let me stop sharing for a moment. Okay, right there, you can see all the formulas for Excel. They're all right there. So you need to know when to use them. And here's the rest of the formulas that you're going to have on both the computer test and the written test. I will give you these. I can drop these off today. Okay?
How many questions is it written? 30?
I don't know. I haven't written it yet. 20 to 30 is probably good. Yeah. Okay? All right. So does that mean you're ready for your quiz? I think somebody came and she didn't hear the quiz, so she left. That's too bad for her. You have another question? Okay. She doesn't watch the videos either, so she won't even know.
1527.
15.27, you want to do that one? 15.27. $15.27, the medical college admission test. Almost all medical schools in the United States required students to take the MCAT. To estimate the mean score mu, you will obtain the scores of a simple random sample of students. The scores follow a normal distribution. And from published information, you know, here I'm going to erase all this stuff because we're going to boil it down to what's the important stuff. You know that the standard deviation is 10.4. What is 10.4? What letter do I use for that?
Sigma.
Is it sigma? Okay. You sure about that? Okay, good. All right, now, Suppose the unknown to you, the mean score of those taking you on your campus is 500. What is 500? Which mean?
Population mean.
Population mean, and what letter do I use for that?
U.
U, because it's the population mean, okay? And I'll put, this is unknown, okay? If you choose one student at random, what is the probability that the student scores between 495 and 505? And this is one student. You're just stretching? Okay, what do you think, Brenda? What is the probability that one student has a score between 495 and 505?
Standard deviation for the population is 10.4.
Okay.
Then you do the 5, so you do two equations, right? The 495,
Okay, so you're going to use the z equation. Which z equation again?
this work.
Which one? You got more than one z equation.
Population, right?
Give me the actual equation.
Okay. The x bar minus population, or minus u, right? Yeah. Over the population sigma. And then you divide it by square root of 1.
Oh, yeah, well, so is it n. Square root of n for now, right? Okay. So we're going to have to do this twice. And the first time we're going to get z equals 495
minus 500
500
divided by
10.4 divided by,
I guess that's where it's lost. I don't understand.
how many students are we talking about? Are we talking about 1, right? Square root of 1. That's going to go away. I don't really need it, right? So this becomes negative 5 over 10.4, which equals
Negative 0.48.
negative 0.48. Now we're going to repeat that process. Okay? We're going to do z equals what? 505 minus 500 divided by 10.4 divided by square root of 1, which equals 5 divided by 10.4, which equals positive 0.48, right? Okay?
Okay, and so then the second time, oh, well, okay, so you do that twice, I understand that now, but then for part B,
Well, we're not done yet. Because we want to know the probability that's between 495 and 505, and I can't get a negative number, so that can't possibly be the correct answer. Because that would say you can't have a negative, yeah, you can't have a negative probability, right? So how do we find the answer?
Chart.
Look at the chart. Or, okay, we're going to do this two ways. The chart answer, and we're going to do it with the computer answer. Okay, the chart answer would be, if I share here, okay, so what am I doing here? I'm going to find negative 0.48, right? Negative 0.48 is that number right there. We'll pick orange or something, okay? So that's 0.3156. And on the positive 0.48 is going to be that number right there, 0.6844. Okay? So how do I finish this? What would Rick do? Okay, you guys are still forgetting to do that. Hey, what am I drawing?
Bell curve.
A bell curve, right? What's the mean? 500. I'm going to convert that mean to a score of? What? What does the z equation change the mean to?
Do we ever do it for 500?
We're trying to do it. That's what we're trying to do. What's the mean of the standard normal distribution?
500.
The standard normal distribution.
0.
It's 0, right? We're converting 500 to 0. I want scores between what two values? 495 and 505, right?
Right.
When I convert that to a standard normal distribution, what are the values that correspond to 495 and 505? Negative 0.48 and positive 0.48. How do I find the area in the middle?
Find both of these scores and then we can subtract it.
We subtract these two p-values, right?
From 1.
So it's going to be this minus that, which equals 4 minus 6 is 8, 3 minus 5 is 8, 7 minus 1 is 6, 6 minus 3 is 3, 0.3688.
That very last part. You subtracted what from what?
I took the big number minus the small number.
And then both of those values, you just subtract the bigger number from the small number.
The big number minus the small
That's
number.
how you get the center.
That's going to be the center. So the probability that one student gets a score between 495 and 505 is 0.3688. Okay? Do you know how to do this on the test tomorrow on the computer? Huh? Ashley, how do you do it?
Well, you'll do everything kind of the same.
Everything's the same up to now, right? Okay, so I'm going to do 495 minus 500 and equals 10.4 divided by the square root of 1. Take the numerator divided by the denominator. Yeah, you can skip it, that's fine. Okay, so it's negative 0.4808, right? It's more decimals. Okay, I'm going to do the same thing again, but now I'm doing 505, right? I get positive 0.48. Then what do I do? Ashley?
And then you're going to use the norm dist.
Norm S dist, don't forget the S. S, what do you think that stands for?
And then you
What does S stand for in norm S dist? Standard normal distribution. Okay? You plug in that. Get 3153. That's a little different. And this is a little different too. Okay, they're very close. And then what? Brenda, take us home. Subtract the big number minus the small number. Now the first time we got 0.3688, this time we get 0.3693. Okay? Which one's more accurate?
Wait, Excel.
Excel is.
So, let me get this going. The equals norm S dist, that is instead of using the chart, right?
Instead of using
It's
chart.
converting your z-score into percentage, but way more accurate.
Way more accurate.
Okay,
That makes sense.
that makes sense. We're calculating our z-score the exact same as on
Exact
paper,
same, yeah.
but then calculating from
But we're
z-score
gonna
to
use more
percentage.
decimals.
Right.
And yeah.
But going from percentage, for z-score to percentage, use that instead of the chart. Because it's gonna be more.
Yeah.
Okay, that
You
makes
need to
sense.
know both methods and you need to know them well. Okay? Because on the computer, I'm going to take off at least 1 point if you use the chart. And on the test Thursday, you won't have the computer, so you have to use the chart.
But the chart's gonna be on the computer
you'll
test,
have the
You'll have it available.
just to
Just don't use it though.
Don't
see
use it.
why is the chart there.
Just
I
just
can
to
take it
make
away.
it
Just to throw us off.
Well, I don't,
I
The reason why it's there is because I don't want to make extra copies.
Okay.
It's not the same thing.
I got you.
Okay.
That's fine.
Brady,
Oh, no, that's a stretch.
what's that? Oh, you were just stretching? Okay. So my question is, should we pause the recording for now and you can take a quiz and you're going to do well on your quiz? Or do you want to keep going and save the quiz for the end?
No, I should do it now.
Do we have to take this quiz?
I feel like we all just took it together.
I agree.
I agree.
Yeah, I learned a lot.
You
know,
need more time to review.
Well, we want to see how much
10
you
minutes,
learn.
and that leaves us like not that much time to review, which I really want to review.
Okay.
Yeah.
Let's take the quiz now. I wonder if I can pause. I'll try to pause, but we might have to have two videos. Yes.
Can you do the B part of that 27?
Oh, the B part, we're not done. Okay. The B part says 27. You sampled 25 students. What is the sampling distribution of their average scores? X bar. I'm going to dry this out.
After the quiz or.
Okay, so let me write that down again. Part B, you sample 25 students. What is the sampling distribution? Lindsay.
But instead of X for one.
Well, you don't need to do all the same steps. Actually, that's not what this question is asking. If you sample 25 students, what is the sampling distribution? We're going to be knocking our foreheads in a minute here.
So don't you do the same?
You guys are answering a different question than it's asking.
Don't you put
So
25
kind of, what you guys are all kind of on the right track, but you're not because it's asking you a different question. What is the sampling distribution? What does that mean? What does it look like? What does the sampling distribution look like? Does that help?
Taking the means of sampling.
I can't hear you. Do you want me to give this to you?
Oh, wait, I think I know.
Brenda, what do you think it looks like? What do you think the sampling distribution of X bar looks like? Narrow what? Narrow what kind of distribution? You're so close. What do you think, Shire? You don't know? Anyone? Ashley?
Is this the equation where you put the
It's not an equation.
Oh, it's not an equation?
If I asked you to draw a picture of the sampling distribution, what would you draw?
Oh, okay.
You would draw a bell curve.
Sorry, I didn't know. I guess I really didn't know this.
Okay? That's what the sampling distribution looks like. It's a normal distribution.
Always?
When we're using the central limit theorem, yes. Okay? Okay, this isn't in the question. Maybe it's in the next part. I won't give it away. Okay. So what is the mean? This is a good bonus question. What is the mean of your sampling distribution? Same as the population, which in this case would be 500. Okay. Part C. What is the probability that the mean is between 495 and 505? Okay, now you guys this is the question you guys were trying to answer. The B.
So like if it just asks you what is the sample distribution, there are no numbers needed. You just have to write the mean and then you
It's a
draw
normal.
that.
Actually, the answer is it's a normal distribution. That's the answer.
And you know that.
I was trying to help you draw it so that you would get the answer.
Oh.
I was hinting at you, and nobody was taking the hint.
And how do we
As
know-
my dad would say, if that was a snake, it would have bit you.
So, wait. Can you say that one more time?
If that was a snake, it would have bit you.
The part before more. The part before that, what was the snake?
This was the snake. Doesn't that look like a snake? It's kind of bowed up there, right? It's warning you, I'm gonna bite you if you don't get away from me. But the answer is, what is the sampling distribution? It's a normal distribution. That's the answer. That's the answer.
What is the sampling distribution?
If they ask you what you sample 25 students, what is the sampling distribution? The answer is it's the normal distribution. I was trying to give you a hint, and it bit you. What?
Don't you have to figure out, because I did it in stat lab, and you have to figure out, we have to do the z-score to figure out a number to use for that.
Are you talking about B or C?
B.
No, that's C.
Okay.
C is correct. Yes, Gage.
So how you got normal distribution, how would we know if it was something else? So like, how did you know just by looking at that it was?
How did I know it was normal distribution?
Because we're doing central theorem.
Because it's the central limit theorem. The central limit theorem says the mean is going to always be normally distributed, no matter what the underlying distribution looks like.
Okay, thank you.
Okay, yes.
Would you ever ask us what is the population distribution? Is that there?
No, because I would probably have to tell you.
Okay. So all I got now, sampling distribution is the normal.
Sampling distribution is always going to be normal, even if the population is not normal.
Okay.
It could be exponential, it could be skewed, it
So
could
even,
be
yeah, even if it says
uniform.
it's skewed or anything.
I would have to tell you what the population was.
Okay.
Or I could say, I don't know what the population looks like. What is the sample distribution?
It's also this.
It's normal.
So even with the one about the bugs and it said this is a skewed.
Yeah, the bug said it was a skewed
You
distribution.
ever asked what is the sampling distribution?
Sampling distribution is still normal.
Okay.
Oh, that's awesome.
That's crazy.
Okay?
Oh.
I can't hear you.
Proceed. Part C.
Part C, yeah, we were trying to finish that, but we were having problems with B. Okay? Part C, what's the probability that the mean is between 495 and 505? Lindsay.
So this is where you do all the parts.
We're going to do this exact same thing we did right here, except for what's the difference?
You have 25.
That one is no longer there, and that's going to be a 25.
Okay.
Okay? Everything else is exactly the same, except for clearly, this won't be the same anymore.
Yeah.
Okay? So Z equals 495 minus 505 divided by 10.4 divided by the square root of 25, and that equals? Brady, what do you got for that answer?
I got, for the whole thing,
For this answer?
I got negative 2.4.
Negative 2.4, and 495 minus 505 divided by 10.4 divided by square root of 25, I'm guessing that's positive 2.4. Okay, so now what we've done is we've changed this from a mean of 500 to a mean of 0. We are now negative 2.4 and positive 2.4 standard deviations away. I need this area here. How do I find that?
Like on this. So you look at the z-score on the chart.
I can look at the z-score on the chart. Okay, so I'm looking at negative 2.4. Is it 2.4 even?
I don't know. I don't know.
Here, let's do the problem here. Z equals 495 minus 505 equals 10.4 divided by the square root of 25. Yeah, I don't need the Z there. Equals this divided by that. That's wrong. Yeah, it should be negative 4.8. Oh, you're right, 500. There we go, now it's 2.4. Okay? Okay, and then this is going to be 505. Okay, so 2.4 to 2.4. So so negative 2.40, so I've got that value there. So that's 0.0082. And then positive 2.4 is going to be 9918.9918. And then Brenda, how do I take this home? Subtract this minus that. I get negative, or I get 0.9836. Okay? And then how do I do this with the computer? Suzette? Oh, don't you want to know by tomorrow? Okay, are you going to be good at this tomorrow? Okay, what do you do, Gage?
So do you do the norm
S dist. By the way, did you know there's one with periods and one without?
I saw that. Will that do something different if you do the one?
Well, you can make that one work, but it's harder. This one's easier. You have to enter more in stuff. Yeah. This one you don't have to. Okay? So I'm going to do that one. Control C, and I'm going to Control V that. So we can compare these two answers. Now I'm going to take this minus that. Okay? So those are similar answers, but they're not the same. Are you going to ace my test, Brenda? Yeah, the probability is way bigger, right? We went from, what was the first answer? 0.36, so 36%, 37% to 98%? Yeah, because I got 25 versus 1 in my denominator, so that's going to make your fraction bigger. Okay? A lot bigger. Good question. So yeah, one student, probability is 37%. 25 students, it's 98%. That's kind of interesting. Okay? All right, do you want to keep going or do you want to do the quiz? Keep going. Does anybody have a question they want to keep going or do you want to think about it during your quiz when you go, oh, I didn't know that one? All right, let's take the quiz. We'll record more if we can. We have a question.